Hey guys, today we're going to be talking about normal distribution, and this is really what we're using standard deviation and all of that mean for. It's to help us calculate the chances of something happening. So let's take a look at what I'm meaning by normal distribution. Alright, so some of you may have seen shapes like this before. This is what's called a normal curve, also sometimes called a bell curve. And it may be a little bit hard to read down here, but right here in the center, this says mean, so our average. Our average is right here in the center. And then over here, I've got -1 DEVs. That stands for deviation. So we are -1 standard deviation, -2 standard deviations, and then -3 standard deviations. On the other side, we've got +1 DEV, or +1 deviations, +2 deviations, and +3 deviations. And what the normal curve is whenever we have something that we say fits the normal curve, what we can do is, if we know how many standard deviations things are, we know the probability or the chances of a randomly selected person or thing in the study of happening. So for instance, in any normal curve, there's always a 34% chance of being from the mean to a +1 standard deviation or a -1 standard deviation. So obviously, if we wanted to find the probability of being between -1 and +1 standard deviations, we would need to add these two together. So the chances of us being within 1 of the mean are 68%. So the chances of being within 1 standard deviation of the mean, so positive or -1 deviation from the mean, is 68% because we add these two together. Now, when we have all of the percents, if we were to add up all the percents of everything that we were ever doing, we should get 100%. But if you were to actually add up these percents that I have written out here, you wouldn't actually get 100%. You'd get something like 99.7%. It's a number very close to 100%, but it's not quite everything. That's because this actually does go beyond positive and -3, but the numbers are so small that most of the time we're not going to be dealing with them in this course. If I were to ever ask you what the probability of something was, of something happening that was greater than positive or -3, you could simply take 100% minus what we had here. Similarly, if everything is 100%, then everything that's bigger than the mean should be 50%. Similarly, everything below the mean should be also 50%. So for instance, if I was just asking you of something that was bigger than 3 standard deviations, you could just do 50 minus the probabilities that you see, the percents that you see here on this side. Or if I was just asking you something that was lower than 3 standard deviations, you would take 50% minus the same 3 standard deviations we see here on this side. Let's take a look at how one of these problems works, and I think it's going to be a little bit simpler than you expect it to be. Alright, so an eel has an average length of 21.1 inches. So we have a whole bunch of eels, and we took the average of all of their lengths, and we got 21.1 inches. And we're also told that the standard deviation of their length is 4.7 inches. So what I'm asking is, what are the chances that a randomly selected eel is between 21.1 and 30.5 inches? So we see here that we've already got the mean, the average. So this is basically counts as a 0, because if I subtract the average minus what I'm told, I get 0. So 21.1 . When we subtract, we get 0. This basically tells us that we are right at the mean, we're right at the center. We want to do the same thing here with this 30.5. So I'm going to do 30.5 minus 21.1. And if I do this, I should get a 9.4. So this is the distance that I am away from my average. I'm 9.4 inches away from my average. But for this calculation, we're not really concerned about the actual inches, we're concerned about the number of standard deviations. So I'm going to label this inches for the moment. But then I want to divide this by the standard deviations right here. So we said that the standard deviations are 4.7. So we're going to divide the 9.4 by 4.7. And this should give us a 2. So we are 2 standard deviations off. Well, this isn't our answer, but this will tell us what we need to look at on our chart. So I'm going to pull this last chart back up. So we said originally, when we subtracted the 21 minus the 21, and we got 0, that was right at our mean. So that means one side is right here, and we said that we were 2 standard deviations away on the high end. So for the 30.5, we were basically right here. So that means that we're asking, what is the probability the randomly selected eel is in between this and this? Well, all we have to do is add up our 2 probabilities here. So 34 plus 13.5 should give us 47.5. So that means we have a 47.5% chance chance that a randomly selected eel is going to be between 21.1 inches and 30.5 inches.